Hello students and good afternoon to you all. So today also I am doing class for class 12 science. The topic is the same topic, that is problems on Rolle's theorem. So in the last online class also we did some problems on Rolle's theorem. So today also we'll do more problems on Rolle's theorem. Okay. So in the last online class we did the Rolle's theorem. We did Rolle's theorem for polynomial of degree 2 and degree 3 expression, right? So in this case we will do Rolle's theorem for the function, trigonometric function, and we'll do for exponential function also. Okay, so let's do this question number 5 of question number 2. So verify the truth of Rolle's theorem for the following functions. So number 5 is f of x is equal to sine square x. Now this is your trigonometric function in 0 less than or equal to x less than or equal to pi. Okay, so let us differentiate it first. Okay, so you should know that in the last online class also I told you that all this trigonometric function, polynomial function of degree n, trigonometric function, inverse circular function, exponential function and logarithmic function, these are all continuous and differentiable in its domain. So what is meant by domain? Those values of x, those real values of x for which this function f of x is defined is known as domain, right? So all these trigonometric functions are continuous and differentiable in its domain, right? So let us first differentiate it. So write down differentiating both the sides. So differentiating both the sides with respect to x. So you know how to differentiate it. So f dash of x is equal to, first of all, it is in the form of x square. Sin x is taken as x. What is the differentiation of x square? 2x. So this will be 2 sin x. Now this sin x was considered as x. So what is the differentiation of sin x? It is cos x, right? So therefore f dash of x is equal to, what is 2 sin x cos x? It is sin 2x. Now the function f of x is differentiable in the open interval 0 less than x less than pi. Okay, now we will write here, therefore the function f of x, the function f of x is continuous in the closed interval 0 to pi. Again the function f of x, the function f of x is differentiable in open interval 0 to pi. And now these two conditions are satisfied. Now we have to find out the third condition, that is f of a is equal to f of b. In this case a is equal to 0 and b is equal to pi. So what is f of x? f of x is equal to sine square x. Now let us put x is equal to 0 here. f of 0 is equal to sine square 0. You know that sine 0 is 0, 0 whole square is 0, right? And f of pi is equal to sine square pi, which is equal to 0 whole square. Sine pi is also 0. What is the value for sine pi? That is also 0, right? So 0 whole square is 0, you know that, right? Sine 0 is 0, sine pi is also 0. So in this case we have proved that f of 0 is equal to f of pi. So I think you have understood it. Now all these three conditions of Rolle's theorem is satisfied. So all conditions of Rolle's theorem, is satisfied. So there exists at least one value of x, that is x is equal to c, lying between a and b. What is a and b in this case? Lying between 0 and pi. Lying between 0 and pi such that f dash of c is equal to 0. So now 2 sin x cos x भनेको sin 2x भने याद छ तिमीलाई मैले यहाँ डाइरेक्ट लेखेँ sin 2x because this is from the formula of multiple angles. 2 sin x cos x is sin 2x, right? So since f dash of x is equal to sin 2x, what is f dash of c? It is sin 2c, you know that. Therefore sin 2c is equal to 0. Sin 2c is equal to 0, right? So now you know that sin 2c is equal to 0 is there. Sin pi is also 0. But if you write sin 0 is also 0, you will get c is equal to 0. But 0 does not lie between 0 and pi. 0 does not lie between 0 and pi because it is exactly equal to 0. You should find out that value of c which lie between 0 and pi. So in this case, you should write sin pi because you know that sin pi is also 0, isn't it? So instead of 0, you write sin pi. So from both the sides, sin will be cancelled. 2c is equal to pi. That means c is equal to pi by 2. As you know that this pi by 2 lies within 0 and pi, right? So here you write, here you can write, therefore 0 less than pi by 2 less than p. So there exists at least one value of x, say x is equal to c, in this case c is equal to pi by 2, which lies within 0 and pi. So Rolle's theorem is verified. So therefore Rolle's theorem is verified. So Rolle's theorem is verified. Okay? So Rolle's theorem is verified in this case. So at the point c is equal to pi by 2 on the curve, the tangent is parallel to the x-axis. Okay? So Rolle's theorem is verified. So you can copy it. We'll do the next question now. Now let's do question number 10 of number 2. You have to verify the truth of Rolle's theorem for the following functions. So f of x is equal to sin 3x in 0 less than or equal to x less than or equal to pi. So this is also trigonometric function. As you know that the trigonometric function is continuous and differentiable in its domain. Okay. So let us first differentiate it. Okay. So differentiating both the sides. Differentiating both the sides with respect to x. So this is your f dash of x is equal to, what is the differentiation of sin 3x? It is cos 3x into, again differentiate 3x with respect to x, that is 3. So or this will be your f dash of x is equal to 3 cos 3x. Now as you know that the trigonometric function is continuous and differentiable in its domain. So the given function f of x is continuous in the closed interval. So you have to write, therefore the function f of x is continuous in the closed interval. That is how to write closed interval within third bracket 0 comma pi. Therefore the function f of x is differentiable in the open interval within first bracket. Within first bracket means it is the open interval 0 comma pi. Okay. Now we have to prove f of a is equal to f of b. What is a in this case? A is equal to 0 and b is equal to pi. Okay. So therefore f of x is equal to sin 3x. So what is f of 0 now? 0 is a here. Sin 3 into 0, which is equal to sin 0, which is equal to 0, right? Again, what is f of pi? F of pi is equal to sin 3 pi. Sin 3 pi पनि कति हुन्छ? 0 नै हुन्छ. As you know that यो value याद हुनुपर्छ. Sin n pi will be equal to 0 where n is any integer. If n is any integer, then sin n pi is equal to 0. You should know it. Okay? So तिमीले यो लेखिराख्नु आफ्नो खातामा sin n pi is equal to 0 where n is any integer, right? So sine 3 pi is also 0. So we have proved here f of 0 is equal to f of pi. Therefore f of 0 is equal to f of pi, right? So here all these three conditions of Rolle's theorem is satisfied. So therefore all conditions of Rolle's theorem is satisfied. Therefore what will write? There exists at least one value of x, say x is equal to c, lying between a and b. What is a and b? Lying between 0 and pi, such that lying between a and b, that is 0 and pi, such that f dash of c is equal to 0. So f dash of c is equal to 0, right? So what is f dash of c now? What is f dash of c here? Yeah, f dash of c bhaneko थियो, since f dash of x is equal to 3 cos 3x, so instead of x you put c. What is f dash of c? 3 cos 3c. It is 3 cos 3c is equal to 0. Is that clear? Or what is the value of cos 3c? Cos 3c is equal to 0 by 3 is always 0. Now cos of which angle is 0 now? You have to solve it. Therefore cos 3c is equal to, now cos ko kun sa angle 0? Cos 90 degree, isn't it? That is cos pi by 2. So it is cos pi by 2, right? So now you can cancel cos from both the sides. So 3c is equal to pi by 2. That means c is equal to, how much is it? It is pi by 6. That is, this pi by 6 lies within 0 and pi, isn't it? This is the value for c. So in this case we have 0 less than pi by 6 less than pi. That is c is equal to pi by 6. That is, at the point c is equal to pi by 6, f dash of c is equal to 0, such that the tangent on the curve at the point c is equal to pi by 6 is parallel to the x-axis. So Rolle's theorem is verified. So therefore Rolle's theorem is verified. So here Rolle's theorem is verified. So this is the answer. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 11 of question number 2. You have to verify the truth of Rolle's theorem for this function, that is f of x is equal to e to the power minus x into sin x in the closed interval 0 less than or equal to x less than or equal to pi, or this is another way of writing this closed interval, that is within third bracket 0 comma pi. Okay, now you know that e to the power minus x is an exponential function and sin x is a trigonometric function. So this is the combination of both the function out here, that is exponential function and trigonometric function. As you know that the exponential function is continuous and differentiable in its domain, and also trigonometric function is also continuous and differentiable in its domain. So this function, that is combination of e to the power x, that is combination of exponential function and trigonometric function, is also continuous and differentiable in its domain. That is e to the power minus x into sin x, e to the power minus x into sin x is also continuous and differentiable in its domain. Okay, so now let us first differentiate this function. So differentiating both the sides with respect to x. You know the product rule, u into v rule, that is f dash of x is equal to, now let us differentiate sin x first, keeping e to the power minus x as it is, e to the power minus x into cos x, right? Then plus Now differentiate e to the power minus x, keeping sin x as it is. That is e to the power minus x into minus 1 into this is your sin x is kept as it is, right? So or f dash of x is equal to, what is common out here? E to the power minus x, and within bracket what do we have? E to the power x plus and minus is minus, this is your sin x. So e to the power minus x, within bracket it is cos x minus sin x. So this is the differentiation of f of x, that is e to the power minus x into sin x. So I think you have understood it, okay? So you have to write down, therefore the function f of x, therefore the function f of x is continuous in the closed interval 0 to pi. Therefore the function f of x, therefore the function f of x is differentiable in the open interval, that is within first bracket 0 comma pi, right? So now you have to check for f of a is equal to f of b. Here a is 0 and b is pi, okay? So what is f of x in this case? So f of x is equal to, what is f of x? E to the power minus x into sin x. So let us put x is equal to 0 in this case. So therefore f of 0 is equal to e to the power minus 0 into sin 0. As you know that e to the power 0, e to the power minus 0 means e to the power 0. E to the power 0 is always 1. Sin 0 is 0, which is equal to 0. Now f of pi. So you can write here f of pi is equal to e to the power minus pi into sin pi, which is equal to e to the power minus pi into sin pi is also 0, which is equal to 0. This is your sin 1 pi. As you know that sin n pi is equal to 0, where n is any integer. So sin pi is also 0. So both are equal here. So you can write, therefore f of 0 is equal to f of pi. Is that clear to all of you? So all conditions of Rolle's theorem is satisfied here. So here you write, here you can write all conditions of Rolle's theorem, all conditions of Rolle's theorem is satisfied. All conditions of Rolle's theorem is satisfied. So what can you write? Therefore there exists at least one value of x, say x is equal to c. कम्तीको पनि एउटा भ्यालु आउँछ कम्तीको पनि एउटा भ्यालु x is equal to c आउँछ such that there exists at least one value of x, say x is equal to c, lying between what? Lying between 0 and pi, such that f dash of x, such that f dash of c is equal to 0, right? So now what is f dash of c? Since we have got f dash of x is equal to e to the power minus x into cos x minus sin x. So instead of x, what will you put? C, okay? So therefore e to the power minus c within bracket, यो x को सट्टामा हामी c हाल्छौं किनभने f dash of c निकाल्नु पर्यो नि त। x को जग्गामा के हाल्दैछौ? c हाल्दैछौ है। So what is the value for f dash of c now? E to the power minus c within bracket, it is cos c minus sin c, which is equal to 0. As you know that e to the power minus c not equal to 0, whatever may be the value for c in this case, whatever may be the real value of c, this e to the power minus c not equal to 0, right? So you should write here e to the power minus c not equal to 0. You e to the power minus c कहिले पनि 0 हुँदैन, whatever may be the real value of c, right? But which is equal to 0 now? Therefore cos c minus sin c will be equal to 0. तो यहाँबाट हामी c को भ्यालु निकाल्छौं अब, or minus sin c is equal to minus cos c, or minus gets cancels. Divide both the sides by cos c. What do we get? Dividing both the sides by cos c, you will get sin c by cos c is equal to 1 or you have tan C is equal to 1. But tan of which angle is 1? Tan of which angle is 1? As you know that tan of which angle is 1? Or tan C is equal to, this is your tan pi by 4. That is C is equal to kati bhayo? Pi by 4. So it is C is equal to pi by 4. Is that clear to all of you? So this C is equal to pi by 4, it lies within 0 and pi, right? So therefore 0 less than pi by 4 less than pi. So 0 less than, this pi by 4 lies within 0 and pi, isn't it? You should prove it. That is f of x, the open interval was given as 0 comma pi. So this pi by 4 lies within 0 and pi, isn't it? So you know that at the point C is equal to pi by 4, that is f dash of C is equal to 0. So what is meant by it? F dash of C is equal to 0. That is the tangent to the curve at any point on it, that is at C is equal to pi by 4, f dash of C is equal to 0. That means the tangent to the curve at the point C is equal to pi by 4 is parallel to the x-axis. That is, tangent at the point C is equal to pi by 4 on the curve is parallel to the x-axis. So Rolle's theorem is verified. So you can write here, therefore Rolle's theorem is verified. So Rolle's theorem is verified. So I think you have understood it. Okay, so you can copy it. Now I will give you the homework. So these are your homework. You can do it at home. Question number 2 is verify the truth of Rolle's theorem for the following functions. That is question number 6, 7, 8, 9 and 12. You can do them at home. Okay. So question number 6 is you have to verify truth. You have to verify the truth. You have to verify the truth of Rolle's theorem for this function f of x is equal to cos square x in the closed interval minus pi by 4 less than or equal to x less than or equal to pi by 4. Okay, you can do it. Number 7, you have to verify the truth of Rolle's theorem for the function f of x is equal to x square minus x minus 12 in the closed interval. This is also closed interval. This is another way of writing the closed interval. That is minus 3 less than or equal to x less than or equal to 4. And also number 8, you have to verify the truth of Rolle's theorem for f of x is equal to x square minus 5x plus 6 in the closed interval in 2 less than or equal to x less than or equal to 3, or you may write it within third bracket 2 comma 3. And also you have to verify the truth of Rolle's theorem for the function number 9, that is f of x is equal to cos x in the closed interval minus pi by 2 less than or equal to x less than or equal to pi by 2. This is another way of writing the closed interval, that is within third bracket you can write minus pi by 2 comma pi by 2. Okay. And number 12, you have to verify the truth of Rolle's theorem for the function f of x is equal to x square minus 4x plus 3 in the closed interval 1 less than or equal to x less than or equal to 3, or within third bracket 1 comma 3. So this is another way of writing the closed interval. त तिमीले यो 5 वटा प्रब्लम घरमा राम्रोसँग प्र्याक्टिस गर्नु यो पहिला सबै रिभिजन गर्ने अनि त्यहाँदेखि यो क्वेशनको एन्सर्स गर्नु, ठीक छ? सो आई थिंक यू क्यान डू इट एट होम, ठीक छ? त आज जति पनि तिमीले प्रब्लम्सहरु गर्यौ, दैट इज प्रब्लम्स अन रोल्स थ्योरम, यो सबै रिभिजन गर्नु अनि यो 5 वटा क्वेशन पनि तिमीले घरमा गर्नु अनि नेक्स्ट क्लासमा वी विल डू मोर प्रब्लम्स अन रोल्स थ्योरम एन्ड वी विल डू प्रब्लम्स अन Lagrange mean value theorem also. So this much is for today. So you can copy it.